Next up, we're looking at example 2. I know that on the previous video I said I would give this as a problem to do, but if you would like to test yourself, you're welcome to quickly pause the video as in now, and then test yourself as we move along, right? So if you want to pause the video, you're welcome to pause. I'll just wait maybe for 5 seconds. And then we're going to work now through these solutions. The first problem here, they say write this equation in this form, right? Ax plus p squared plus q, right? And they say here, what are the maximum or the minimum value of y and x? And then on the last problem, they ask us to draw the graph, right? And I want you to quickly note that don't let the format ax plus q confuse you, right? Remember that if you look at previous examples, how we actually wrote our case, we wrote it in the form of ax minus p. For me, I prefer working with that instead, working with x minus p instead of x plus p. But you'll see shortly what I mean by that. So let's quickly start. So they ask us to write this in this format. Remember that when we're doing the derivation of this equation, we use completing the square, right? And this is how we complete the square, right? So now I'm just going to quickly show you how that is useful. So because at times it might come up as a question. They won't say complete the square, but that's what they mean. So when they say write this equation in this format, that's what they mean by that. So we'll have here y equals 2x squared minus 3x plus 4, right? Remember that the first step is we want to achieve a 1 here, so we'll need to factorize 2. We'll have x squared minus 3 over 2 x plus 2. So we factorize 2 because 2 times 2 is 4. And then next up, we said we look at what the middle term is. And what we do is so let me just write this down. X squared minus 3 over 2 x. And I've said before is we add half the middle term's value. So minus 3 over 2 squared, and then we subtract the same half minus 3 over 2 squared. And since we're adding it, this is 0, but it just helps us in writing the equation rather more differently. And then we have plus 2 here. If you try and simplify this, we'll have 2x squared minus 3 over 2, right? X, and this will become plus 9 over 16, right? And then this will become minus 9 over 16, and then we have plus 2. And remember, we said we're going to have these two here because I'm not sure if you remember again, this is what we also did here when adding. We added these two alone and we factorized these two alone. So we're going to do the same here. So 2, so when we factorize here, we have x. So and remember that we said when we factorize, if we have a plus, we look at what this value of the middle term is. We'll have a minus, x, a minus, and it's easy because it's 1, so we don't have to stress about this. And we square root of this will be 3 over 4, 3 over 4. And then if we add these two we will have plus 23 over 8. And then we simplify this a bit. We have now 2x minus 3 over 4 squared. That times that, it's a square, plus 23 over 8, right? So do you notice now we have this in this format? We have in the format of x, right, minus 3 over 4 squared plus 2 over 3, which is what they wanted there. So that's what I meant when I said just be able to complete the square, and then the calculations will lead you. So we have this in this format, right? So we already have this in this format, and then now the second question asks us to what are the minimum and the maximum value of the equation. And I just want to bring your attention to what we had earlier. We said after writing this equation and completing the square, this represents the maximum y value, right? And notice we have this in this format here, right? We have the a on the outside, and here we have this here, which is we could just safely say that this represents the y value of the turning point. So that's the power of writing this in this turning point equation, so to say, because now when you have simplified this, you already know what your x and y value of the turning point is. So this is the y value of the turning point. All right. And then next up, remember the method we used to determine what the x value is. We said, if we looked at this, we said, okay, in order for this to be a maximum, this term must go to 0, this term. And then we wrote x plus b over 2a, and we equated that to 0, and we solve for x. So we need to do the same thing once again. So we take this term, so we write x minus 3 over 4, we equate that to 0, and then we solve x equals 3 over 4. So now do you see we have our value, and then we have our value here. And how do we know whether these are maximum, minimum? So we have our a outside, and our a is positive, and we said the shape of this, in the case whereby this is positive, it will be like this. And if it's a case like this, the x and the y are said to be minimum. However, if it happened that the gradient is negative, we would say that the y and the x value of the turning point are at max. So we can just say these represents the minimum, both. So the coordinates are 3 over 4 and 3 over 4 and then 23 over 8. So now remember the question asked us to draw. So in order to draw this, right, we would use so we already know what the coordinates of the turning point is. We would go back to this equation and use the method we used previously to determine the other values of the graph. That is because we already have our a, so we are sorted with that. We would have to determine using that equation what the y-intercept, and then determine the x-intercept. But now the turning point, since we already have our equation in terms of turning point format, that would be sorted already. So that would be fine. And if you want, you are welcome to use this equation again, this, right? So if you want, for instance, to determine what the y-intercept is, you set this equals to 0, and then you're left with 2 bracket minus 3 over a squared plus 23, and then you're going to be able to solve what your y-intercept is. Whereas if you want to solve what your x-intercept is, you set y equal to 0, and you determine the rest of the values. So you're welcome to experiment with that. I won't give out the solution, but if you try it out, this is how the graph will look like. So I want you to try that. It will look like this, and then the y-intercept will be 0 and 4, and the equations of the turning point we already have. It's 3 over 4, 23 over 8. So just try that out and see. 23 over 8, and try that out if you see if you'll get the same graph as I did.